10, how come, like, I have 4/3, but how come 0 isn't also a possible answer?
Is it in the interval?
Since
It
0
is
comes.
in the interval, yes. Okay, so there's another reason then.
We got the denominator. Nope, which is the bottom one. It's the denominator, right? Okay, get the denominator right on the right. Get the numerator.
Oh, it has to be in the interior of the interval. It can't be on the endpoint.
Oh, okay.
That's why.
Oh boy.
Okay, was that it?
We got 4 and 8 wrong.
What did you get for 4?
Yeah, I got 3.
Okay. Alright. I didn't know if you were close. But it doesn't.
Guess not. Must have just made mistakes.
You did it together.
Generally.
Yeah, we checked it.
Yeah. We did our own work.
And they're like, oh, where'd you do this?
Yes, we got this. Except for on number 8. I don't even think we
I
got
don't
the
think
same.
we did that one. I did.
Well, you got 3. I got 3.
Yeah, we did this one, but I don't think we did 8. I have like square roots in them. 100 plus square root 5.
I have 25.
Yeah.
You get 2.
Yeah.
Okay, so the slope is 2 minus 7 over 3 is the slope, right?
I got -3. But
2 minus.
I think we just wrote it.
Yeah, it should be positive 3. So then the derivative is plus.
So that's probably what screws up.
So then you have 3 equals -3x squared.
We set it to 0.
Yeah, so 3x squared minus 8x plus 3 is 0. And you had minus 3 there. Everything else you did the same. Okay. That should fix 4 then. What was the other one you said? 8? Was 8 the other one you guys wanted to do?
What was the answer for number 4 again?
4 plus or minus the square root of 7 over 3. Do that?
Why is it -2 on the top and not -4? Oh, yeah. Oh. That would have made my life so much easier.
Do you have that,
I
Olivia?
think I dropped the, yeah, I dropped the 1/2. So then I didn't move it to the bottom, because I just multiplied, like I didn't. And I don't know.
You didn't have a 2 on the top? Or you dropped this one?
Yeah, I dropped that part, so
Oh.
then I never, yeah.
Okay, so you should have -2√5/5 equals -2 over square root plus 20 to the 1/2. See if you can go from there. You should get
Then you can cross multiply.
-15/4. Yes, you can cross multiply.
Because I got -25/4.
How come there's a root over the 4x plus 20?
Because I changed it, this is 1/2.
I
It's the
still
same
got
thing as the square root.
-25/4. Oh, no, I didn't. Okay, yeah, I got it. Just did it. I got it.
Good. There's probably more than one way of going about that algebra. I don't know, is that how you did it? Skylar? Did you work? I mean, order-wise, you could probably do it a couple different ways. But I just recognize that if this is to the 1/2, that means a square root, and if I have a square root times a square root, I can put all of that underneath the square root sign together.
I just can't do simple math because mine is just adding and subtracting. That's how I get the numbers.
You can do simple math. We all make little mistakes.
That's just always where my error is.
Yeah.
My negative signs are wrong.
How come, I get why you have to square the square root to get rid of the square root, but how come, we don't have to multiply the other side by the root? Like how come we
You
just
do the same
square
thing that
You
you
have
do
to
one
square
side
it.
and the other side. So you have to square it.
This root is part of the, this is part of the problem. Like that is the number. It has a square root with it, that has a square root with it. We didn't take the square root of that side. It was already there, it was part of the problem.
Okay. I guess I just get confused because when I used to do it, I'd multiply that side by square root 5 parentheses 4x plus 20. So then I'd do it to the other side, but that's different, so I don't know why.
Squaring it, yeah,
Mm-hmm.
is different than that.
Okay.
Good? Okay, so you guys are good on all of that then? Okay, go ahead and get out your notes. We're gonna talk about finding where a function is increasing or decreasing. And I feel like we've sort of talked about this before when we were doing those motion problems, those motion along the line problems. Do you remember that? You guys had a hard time with that, and where you had to like say when it was moving left and when it was moving right.
Oh. I didn't like those.
It's very much like that. But we're gonna formalize it now, so hopefully that will help a little bit. Where you have a specific process. Okay, so when the derivative is greater than 0, then it's increasing. Remember, the derivative is the slope of the function, and so if the slope is positive, then the function would be increasing at that point, so that makes sense. And if the derivative is negative, or if it's less than 0, in other words, then it would be decreasing, right? So if it's the slope and the slope is negative, then the function would be decreasing. So to determine whether that is the case, we're going to find the derivative and then set it greater than 0 to figure out where it's increasing, and then set it less than 0 to figure out where it's decreasing. So in this example, where is the function increasing and where is it decreasing? We will find the derivative, which is what?
3x squared minus 4.
Good. And then we will set it to be greater than 0.
Would you just choose any number?
No, like an inequality. Greater than 0 and less than 0.
Oh.
And then we solve them.
Never. Because isn't there some sort of rule, like if you divide by a negative number, you have to flip it? Okay. So I always get that confused.
Yes, with inequalities, if you multiply or divide by a negative number, you have to flip it. So yeah, x squared is greater than 4/3, so x is greater than plus or minus 4/3.
How come it's not plus or minus square root?
Hmm?
How come it's not plus or minus square root 4/3?
Oh, it is, sorry.
Oh.
You just drop the fourth.
No, you
the
can't
square
do
root.
that.
Yeah,
No.
like, that makes life real easy.
No, that's what it would be, you're right. Okay, and then on this side, we'd have 3x squared is less than 4. I messed that up a little bit. Because of the whole negative thing. So this is really, okay, let's go back. We're all good to this point, yes. Right, okay, so if it's positive 4/3, then it's fine, so x is gonna be greater than the square root of 4/3, but the negative one is where there's an issue, so it would be x is less than negative. And then we have to do the same thing over here, so x is less than, it's a positive, or x is greater than the negative. the fun part is writing the intervals and interval notation. So where is the function? This would be increasing, so it's increasing on the interval of negative infinity to negative square root 4 over 3. And also from square root of 4 over 3 to infinity is increasing. You guys see where those are coming from? Yes? Okay. And then it's decreasing when it's greater than negative 4 root 3 or less than positive 4 root 3. So that would be all in one interval. So from negative root 4 over 3 to positive root 4 over 3, it's decreasing. Right. So don't look at the directions just yet, we're gonna just find the intervals of increase and decrease. It tells you to find the critical points, and when we find the intervals of increase and decrease, that will lead us to find the critical points as well. So, let's do the first one together and then you guys can get started. Okay, so find the derivative, which would be what?
Negative 4x to 3 plus 6x.
Okay, good. And then we set it to be greater than 0 to find out where it's increasing, and less than 0 to find out where it's decreasing. So, to solve this, we probably want to factor out an x, or maybe even a 2x, if you want, or maybe a negative 2x to get rid of out of the leading coefficient. So we have 2x squared minus 3. Don't know what to do. Do it. Okay, I'm starting to think we might want to do a slightly different approach with these. An example. If we set it equal to 0 instead, then we can sort of kind of do what the directions were asking us more so to find the increase and decrease. Yeah, let's do that. Cause these are a little bit more. Sorry. Let's go with equal. So this will give us the critical points. And that makes it a little bit easier. So if it's equal to 0, we'll have x can be 0, or 2x squared minus 3 can be 0. So 2x squared equals 3. So we have critical points at 0, positive square root 3 over, let's go, negative square root 3 over 2, 0, and positive square root 3 over 2. So, I was debating showing you this earlier, so let's just do it now. And I've sort of done it with you before, but we'll put them on a number line. So, just in the order that they come on a number line. And then we have to determine if the derivative would be increasing or decreasing, or the derivative would be positive or negative in each of these intervals. So let's get a estimate for negative square root 3 over 2. A decimal estimate. $1.22. Okay. Alright, so if we test a point that is less than that, and we have to test one in all 4 sections to figure out, and then we won't have to solve inequalities. So this seems longer than the example, but you won't have to deal with the confusion of the inequality parts. So if we test f prime of -2, that would be out here. We'd have -4 times -2 cubed plus 6 times -2. We just need to know if it's going to be positive or negative. Then we'll test a point from 0 to -1.22, so we can do -1 would be in there.